Welcome to our IE 534 project presentation video called Dishing Out the Dollars. The project members are Jenna, Aring, Sawvell, and Haley Swartz. In this video, we will go over the project introduction, problem setup, our data collection, the calculations we made without our model, and then the creation and execution of our model in MATLAB, the results of that model, our conclusion, and then our references.
And now to introduce our project, we invested in 10 food fiber and grain seed oil products in the stock market. We chose food because it's very sustainable and everyone is craving their favorite side dishes for Thanksgiving. Each gal invested $1,000 each in hopes of a get-rich-quick for our Thanksgiving trip. We invested in the stock market in hopes of making a profit in 1 month. We collected prices for our stocks on October 8th, and then we recollected on November 5th for our selling price.
The next 3 slides will show the data that we collected for our project. On this slide, you can see the graph that we collected from Investopedia. We first started with the line graph of the closing price of corn and then added the next 9 stocks over the course of a month in order to see the trends, the variability in the stock, and also to have a nice visual on what the prices were. On the next slide, you can see the buying prices for all of the stocks summarized into the table. And on this slide, you can see the selling price of the stocks also summarized in a nice table. We also included the deltas of each of the stock prices so you can see how much they change, whether positive or negative.
Since we cannot predict how the stocks will perform, we looked at the historical trends from the previous month. We chose arbitrarily and without an algorithm to buy the number of stocks shown in the first column in hopes of making the most profit. With the numbers selected, we made a total profit of $94.95. This would reflect how amateur investors would decide to invest in the stock market. Next, we will discuss the creation of our model and algorithm.
We then formulated a linear programming model to represent the data to maximize our profit. As shown, the X sub j variables are the number of stocks of item J the model suggests we buy. The Y sub j variables represent the amount of money spent on the stocks on the starting date. We maximize profit by summing the delta of each stock multiplied by the number of stocks bought. We only had $1,000 per person to invest. Therefore, we had to set an upper bound on the summation of the Y variables. We set the X variables as non-negative integers to ensure that we would not buy partial stocks. The buying price was demonstrated by multiplying each buying price by the number of stocks suggested. We used MATLAB as a computer solver to complete the model. As shown, the C matrix includes the delta values. The $3,000 maximum was represented by the inequality constraint matrices of A and B. The equality constraint matrices of AEQ and BEQ represent the buying prices of all 10 stocks. In order to remain non-negative, all variables had lower bounds of 0. The upper bounds were all set to infinity in order to provide flexibility for the model. We then used int_con matrix to tell MATLAB that all X variables are required to be integers.
The results of our model are shown on the screen. Our model suggested that we purchase 1 stock of corn at $16.21, 1 stock of cocoa at $2,086, and 8 stocks of coffee at $111.86. The return on our investment is as follows. Our total cost summed up to $2,997.01, and our total amount made back, subtracting that cost, is our total profit, which equates to $268.25. This means we made $89.42 in 1 month per person.
Since we cannot tell the future, we only made $94.95. If we had our model at the beginning of October, we would have made $268.25. As we are just intermediate in the linear programming world, a professional would have been able to use more historical data to predict values more accurately.
Here are our references. We used Investopedia for our data collection, and we also referenced Dr. Wang's Google site, specifically Lecture 3, for his words of wisdom.
Let's go State!